All right, so because the vertex is at 0, 5, this is now what kind of hyperbola? Vertical, which means what letter comes first? Y squared minus x squared. So I know I'm going to eventually fill those in, right? The vertex being at 0, 5, that 5 is what? That's just the A by itself, right? And then the focus, the 8, 0 is what? C. So if 8 squared equals 5 squared plus B squared, 64, 25. And B squared is 39. So this goes over your A, which would be squared. 5 squared is 25. This goes over your B squared, which is 39. Raise your hand if you got it right. Okay, good. Questions on it? Okay, this time you're given the functions equation, and it's asking you for the vertices, the covertices, and the asymptotes. So again, the first thing to identify is what kind of hyperbola this is. So x is first, right? Which means what? Horizontal. Okay, there's no shift on my center, so my center is 0, 0. This would be the center. This is my A squared, so A is 6. This is my B squared, so B is 12. That means that if it's horizontal from the center, I count right and left the A. So I'd go 1, 2, 3, 4, 5, 6. Those would be my vertices, 1, 2, 3, 4, 5, 6. So the vertices are at 6, 0 and negative 6, 0. And then I count up or down the B if it's a horizontal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are my covertices, which would be 0, 12, and 0, negative 12. And then my asymptotes, because this is horizontal, my asymptotes are y equals plus and minus b over ax, or y equals plus and minus the b, which is 12, the a, which is 6, x, which reduces to plus and minus 2x. So vertices, covertices, and asymptotes. Questions on that one? Obviously would be my vertical, no, my horizontal. This would look like this, and this, and this, and this. And the asymptotes would go through here, would go up to and over 1 all the way up to the box, completing the box. There, and there. All right, so this one, the fourth one, the y squared comes first, telling you that this is what? Vertical. Which means that when I graph it, I'm going to count up and down my A. My center is still at 0, 0, because I'm not shifting the x squared or y squared at all. This is the A squared, making A 6. This is the B squared, making B 5. So I'm counting up and down the A this time because it's vertical. 1, 2, 3, 4, 5, 6. Which is 0, 6, and 1, 2, 3, 4, 5, 6, which is 0, negative 6. Those are my vertices. And then my covertices this time are on the x-axis. So I add the b, but I add it to the x. I'm changing it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5, 0, and negative 5, 0. And then my asymptote is vertical, which means it's A over B. So I would do y equals plus and minus 6 over 5x, which is what would happen if I drew through this little box. This way, and then my vertical hyperbola would look like that. So you can do these, and the more comfortable you're going to get at these, you can do them without graphing it if it didn't say to graph, which I think your test doesn't ask you to graph. It's just asking you to shift your vertices. So you just got to think about it. Like if it's horizontal, then I know I'm shifting the x's with A. And if it's vertical, then I'm shifting the y's with the A. And then the other one would be with the B. So I think the picture helps you if you can't understand it, if you haven't fully grasped it. It's easy to graph it. But if not, you definitely don't need it. All right, now we're talking about a shift in the points, right? So if I've got something added to or subtracted from the x and the y within the parentheses, my center is no longer at 0, 0. So the center is always the opposite. When I take out that, if I have x minus 3, what's the x coordinate of my center? It's a positive 3. Good. And then the y would be what? Negative 1. So 3, negative 1. So instead of starting at 0, 0, 1, 2, 3, I'm starting at 3, negative 1. Is this horizontal or vertical? It's horizontal, which means that my shift is going to happen along the x-axis for the a. So if this is a squared, then a is 6. Take that 3 and add 6 to it. So 3 plus 6 would put me at 9, negative 1. And subtract 6 from it. 1, 2, 3, 4, 5, 6. 3 minus 6 is at a negative 3, negative 1. So those are my vertices. I'm shifting the x. And then the co-vertices, I would shift the y. And because this is b squared, b is 12. So to my y, I'm adding 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And subtracting 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 down here. And if I keep my x but change my y, my x is still at 3. My y is 12 less than negative 1, which would be negative 13, and 12 more than negative 1, which would be a positive 11. And then your little box would get drawn, your hyperbolas, and it's horizontal, so it goes along from left to right. And the asymptotes, because it's horizontal, it's plus and minus b over a. That would stay the same, but you have to account for the k and the h. So I put in here whatever is here. So this is y plus 1 equals plus and minus. B is 12. A is 6. And then x minus 3. So y plus 1 plus and minus 2 times x minus 3. So the asymptotes still match. If it's horizontal, it's b over a. If it's vertical, it's a over b. But this time, instead of just keeping it as y and x, you have to subtract the h and the k. So whatever's in the parentheses in your initial should end up being with those terms in your asymptotes. Mm-hmm.
This is the one that I was confused about with vertices.
All right, so the center this time shifted negative 2, 1 would have been your center. The y comes first, so this is vertical. So for my vertices, I shifted the a value, but on the y coordinate because it's vertical. So I would have got negative 2, negative 5, and negative 2, 7 by adding and subtracting 6 from the y. And then the co-vertices would be the horizontal points from the center. So I left the y the same, and I changed the co-vertices by subtracting and adding the b to the x value, which is the negative 7 and 3. And then the asymptote, it's a over b because it's vertical. A is 6, b is 5. And then I made sure to include the k and the h so that it matches my original equation. Draw your asymptotes, draw your points, and then you get your vertical hyperbola.
You see where it says y minus 1?
Mm-hmm.
You don't change it to -1?
No, this one will always match this, and this one will always match the x. So whatever's in your original equation. Because when we take it out, it's y minus k. So when we take that out, the k is positive 1. When we put it back into the asymptote, it's still y minus k. So it's y minus 1 again.
You don't change it?
Nope. You change it when you pull it out and you're giving the point. So the point there gets changed, but the equation itself doesn't. Okay. So, I mean, the good news is as of now, the shifted center is not on your test. I don't foresee it changing. Don't know that it will, but I don't foresee it changing. You just have the ones where it's 0, 0. Ones. Okay, so parabolas. So again, just like with hyperbolas, you have two options. You either have a parabola that opens vertically or up or down, and then a parabola that opens horizontally, which is the faces right and faces left. So if it's up or down, then it's y equals plus and minus 1 over 4p times x squared. The positive one opens up, and the negative one opens down. And then if it's x equals plus or minus 1 over 4p y squared, this opens right or left. The positive opens facing to the right, and the negative faces open to the left. The focus falls inside the parabola, and the directrix falls outside, and the parabola points away from it. But the distance from the vertex to the focus or the vertex to the directrix is the same, and that's your p-value. So this says write the equation for the parabola with focus being at 0, 0, and the directrix at y equals 4. So the first thing you want to figure out from this is which way does it face. So if my focus is at 0, 0, and my directrix is y equals 4, what kind of a line is a y equals? Vertical or horizontal? When does the y never change? Vertical or horizontal? Do the points along a vertical line, does the y change? Yes. How about a horizontal? No. So this is a horizontal line that runs through positive 4. Which tells you what kind of parabola do you have?
Negative.
A negative one that faces downward. And it's halfway between these. So the P is 2. And the fact that it faces down tells you it's a negative x squared parabola. X squared is up or down, positive is up, negative or down. So then I know it's a y equals negative 1 over 4 p, which we said is 2, x squared. So from the information they give you, you got to figure out which direction does it face, and then figure out what the p-value is. Depending on what direction it faces is how you'll write your equation, plug the p in, and then simplify it. Okay, I'm just going to go because I don't want to run out of time, so we're going to do these last ones. So it says write an equation for the parabola with a focus at 0, 0 and directrix at x equals 6. So focus is at 0, 0. X equals 6 is what kind of line? Vertical, right? 1, 2, 3, 4, 5, 6, right? Because all these x's would be 6. That's how I know it's vertical. So that means my vertex is halfway between the two, and the p, and it faces which direction? Towards or around the focus. So this is going to be a leftward facing parabola, which tells you what about its equation? It's a negative y squared one, right? So this is x equals negative 1 over 4p y squared. What's P?
P is 3.
Good. So this is x equals negative 1 over 4 times 3 y squared. X equals negative 1/12 y squared. Ian?
Why was it negative 1/4p?
Because it points left. So if it points right, it's positive 1 over 4p. If it points left, it's negative. Lauren?
Oh,
How do you know to go right? Oh, because it's positive.
Good? Yeah? Okay, so then the last kind with the parabolas were the reverse. I'm going to give you the equation. You're going to give me all that information based on the equation. So the first thing you should be able to identify is which way is this facing. So if I have a positive y squared, then which direction is this facing? Y squared would be right or left, and if it's positive, right. So this is going to be a rightward facing parabola. Now my vertex comes from the opposite of what follows x and the opposite of what follows y. So the vertex, which is your h and your k, would be negative 2, 3. So already I know what it looks like and which direction it faces. Now I got to find p. So if 1 over 16 equals 1 over 4p, then I just focus on 16 equaling 4p, and p would equal what? 4. Which means from this point, I'm going to go 1, 2, 3, 4 to the left, and that's my directrix. 1, 2, 3, 4 to the right, and that's my focus. So if I was at negative 2, 3, oh, this should have been negative 3. I moved it the wrong direction. Sorry, guys. This is negative 2, 3. That's your vertex. Rightward facing. 1, 2, 3, 4. That's your focus. So I went to the right 4, which means add 4 to that negative 2, and I'd get 2, 3. And then 1, 2, 3, 4, and that's your directrix. Negative 2 minus 4 is negative 6. And it's an x equals because it's vertical. So ignore this one, I shifted the vertex wrong. And then the last thing it asks for, right, is the axis of symmetry. Axis of symmetry always runs through the vertex, splitting your parabola into 2 symmetric pieces. If it's a horizontal line, it's a y equals, and it's y equals whatever the y coordinate of the vertex is, which in this case is 3. So this time the x is squared, it's a positive, right? Which tells you what does this look like? Vertical pointing up, right? So I know that's true. What's the vertex here? Good. Opposite of what follows x, opposite of what follows y. So 1, 2, 3, 4, 1, 2. And I know it opens upward. 1 over 12 equals 1 over 4p. Ignore the top, and I'd get p equals 3. So I go up 1, 2, 3. That's my focus. I go down 1, 2, 3. That's my directrix. So focus. The x stays the same, it's 4, but the y goes up 3 places, which is 5. And the directrix, it's a horizontal line, which means it's a y equals, and I subtract 3 from the y, and I get negative 1. And then the axis of symmetry runs vertically through that vertex. So it's an x equals whatever the x coordinate of my vertex was, which is 4. So if you need the extra practice on this stuff, go back to the quiz assignment. Go back to the individual assignments on 12.4, 12.5, okay? Because tomorrow we'll spend the time reviewing 12.7 so that you're ready for your quiz on Friday, which is 12.7. So this is on your test next week, but the quiz is just 12.7, okay?